whilst everybody else was no doubt enjoying their bank holiday weekend, I spent mine making a set of phoenix wings for a friend's fancy dress costume, and it's basically chopped out of this heavy duty 6-ply corrugated cardboard, which bandsaws quite well actually, and it's fairly light and you can paint it. And this actually came from an octobin, which is a pallet sized box that's widely used in the plastics industry for storing granules. So if you ever need any structural cardboard, it's worth contacting any local large moulders and see if they've got any that they're chucking in the skip. So it's been painted and covered in glitter, so I shall never see the end of that stuff. It's all over the place, and it's designed to fit inside an old rucksack, which is cunningly hidden inside a red t-shirt. So as good as it looks, this isn't actually the subject of the video. I think it'll suffice for what it's going to do later in the week at this fancy dress thing. But what I found whilst installing the flashing lights around the edge is these things actually have some interesting properties which makes them quite hackable. So I've been having a bit of a play with that, and I'll show you what I've discovered. And since that section was inevitably a bit dark, I thought I better just turn the lights on and show you my crummy artwork and the thickness of these things, give you an idea of just how solid this stuff really is. And a rucksack covered in glitter. Anyway, moving on. My original plan was to run these LEDs off a 9-volt battery and basically put them in groups of 3, but unfortunately it turns out that when you put them in series they all start blinking in sequence. They're all locked in phase, whereas if you have them in parallel they all start running completely independently straight away, and this is the effect that I was after. So that was a little bit awkward because it would have meant I would have had 5 or 6 different sections around the wings, all of which were flickering in sync, whereas what I really wanted is every single one running independently. So I had a bit of a think about why it's doing that, and if we have a look at the old school rainbow flashing ones, you can see that they all kind of start in sync, but once they start flashing they quickly get out of sync. But when you wire these in series they do flicker quite a lot. If you put them in parallel, it does the same sort of thing. They all start up the same sequence and then quickly get out of step once they start flashing, and that's nowhere near as flickery as putting them in a series configuration. And I think basically what they've got going on in here is some kind of exclusive or shift register on an RC clock, which is then just creating random numbers and possibly counting those and then turning them into semi-random flashes. But because it's only a pseudo-random sequence, obviously they all start out the same way before they start doing their thing. But coming back to this, that was the issue that I was trying to solve. In the end I fixed it by simply doing a 3-volt system like that, but it got me interested in playing around with these and seeing what I could do. First thing that I realised would be possible is if I use some non-standard LEDs which aren't flickering. These are 10mm white ones, but by putting them in series with a flickering LED, obviously they're simply feeding off that one. As soon as this one closes the circuit they light up, as soon as it opens they go off. So whatever this one does, these play follow my leader, so it's quite a useful way of creating flickering LEDs even if they're not actually flickering. As for getting the 3 flickering ones in series to do their own thing, I thought I might try just bypassing one with a capacitor, and if I perhaps lower the current a little bit here you might be able to see these, but the middle one is now flickering out of step with the other 2 because that capacitor I've added is basically acting as a small battery for it, so when the others switch off it's still got a power supply, and you can see that if I unplug the power you can see how that capacitor is slowly fading it down. So that works, but I found you need quite a large capacitor to make this work. I think this is 2200 microfarads, so a little bit bulky for doing this on quite a lot of LEDs, but that does work. Another way of sorting this out so that they all blink independently is to bypass them with some resistors, and this isn't a fantastic way of doing it because obviously you're wasting quite a lot of current through those resistors. Probably, well, I'm getting a reading here of about 15 milliamps, so I suspect most of that is going through the resistors, but these are kind of a little bit out of sequence now. It's not perfect, not as good as the capacitor effect, but it does just break them up that little bit and just make it so that there's a little bit more flicker between them rather than all of them running at once. The other thing I thought I might try is, well, what if I'm running them off, say, a 3-volt supply, and I can't put them in series then and get a non-flickering LED to flicker, but with the addition of a resistor from the cathode on the flickering LED down to ground, that generates a small voltage across it when the LED is on, and I'm simply tapping that into the base of an NPN transistor, and then my non-flickering white LED is flickering, and so that's running on parallel in 3 volts rather than having to put them in series on a higher voltage. Well, just for a laugh, I thought I might have a go at making my own flickering LED, and the way I decided to do this was to make use of these simple astable multivibrators, which are just a couple of switch transistors and an RC timing constant, and by changing the resistance and capacitance values you can change the frequency. So I thought, what if I take a load of these all running at different frequencies and mix them all up? That should create a fairly chaotic waveform which isn't strictly random, but if you've got enough of these then you can get something that's pretty reasonable. So there's 4 of those oscillators on here, and then I've taken all of the 8 outputs and basically capacitively coupled them all together, and then I'm feeding that into a 358 dual op amp, and the first stage is just being used as a buffer just to tidy the signal up, and then the second stage is being used as a comparator, and I had to play around with the threshold value there, but once you've got something that works, I'm just taking the output from that through a transistor and dumped a bit of capacitance on the base so that it's not quite square wave output, it's a little bit more flickery and more mellow, but it's working reasonably well, and in some respects I think it's actually better than the pre-built one with the inbuilt chip. So yeah, if you want something that's a bit different from this, I'd probably use a microcontroller, but certainly you can do it out of analog components if you want. So my final question obviously was, how exactly are they implementing this flicker effect? As we can see on the scope screen, it's actually a kind of pulse width modulated signal they've got going on here, so it's certainly not a pure analog thing like I was playing with, and again I suspect what they've got is some kind of pseudo random pulse sequence coming out of this thing, and it's just counting the 1s and 0s, and when it gets a certain combination it goes low for one period of time, and if it gets a different sequence it goes low for twice or 3 times the length or whatever. So obviously a fairly clever implementation. The fact that they go out of sync fairly quickly suggests that there is some kind of inherent randomness in there. Maybe they're exploiting a temperature effect on the semiconductor, or maybe there's some genuine noise amplification going on. Not entirely sure, but yeah, they're quite useful little things, and you can do a few clever hacks with them with not a great deal of other components.